Okay folks, we're almost done. We're going to look at question 7 and question 9 together. They are both questions where you absolutely have to interpret the concepts that are being examined. Okay, question 7, the first thing says f of x. Before I start, please, I'm reminding you to subscribe to my channel and also to like if this video helped you. Okay, so f of x, they've given us as this set of factors. Remember, these are factors. So f of x is already fully factorized. Okay. F of x is x squared minus 3 times 3x minus 1 times x plus 2. The question was asked for a total of 5 marks. Now they're asking us solve for x if f of x is equal to 0, clearly here, and x is an integer. So that tells us what? The root that you're looking for has to be an integer root. Here, x has to be a rational number. Now remember what the definition of a rational number is. It's a over b, where a is an integer and b is an integer. Okay. So a must be integer, b must be integer. Then the number is rational. It's not something over something. This has got to be integer, that has got to be integer. So you can't have the root of 2 over 3. That's not a rational number. So remember your definition of a rational number. An integer is plus or minus a whole number. And then the real number are those that we have basically as irrationals. The biggest, so the smallest set here will be that the result for x is irrational. So those are typically the square root of 2, the square root of 3, or the root of 3 over 2, etc. Okay, so let's look at the first one. To answer A, if I look at these, I'm like making this equal to 0. The only integer root will come from x plus 2. So that root will mean x is minus 2. As simple as that. Okay, it's the only integer, so it's a negative integer, a negative whole number here. For B, a rational number, we're looking for a solution from here where the top is integer, the bottom is integer. Now, the only one where that is going to happen is where 3x minus 1 is 0. Now, please don't fall into the trap here. 3x is therefore 1. Folks, for some reason you guys say it's 3 divided by 1. It's not. We need to get rid of the 3, so we divide both sides by 3. So x will be 1 over 3. Is 1 an integer? Yes. Is 3 an integer? Yes. So that's the rational root from this polynomial that they gave us. The last one is so that x is real. Now the only one that's going to give us a real is the first bracket. We want to know where x squared minus 3 is 0. Well, this will happen where x squared is equal to 3. Now please, again, you are going to initiate the square root. So the moment you do that, there's a plus or minus. So what is x? X is plus or minus the root of 3. Okay, so this here is real, that is rational, this there is integer. Okay, that's your question 7 for a good 5 marks. Let's move to question 9. Question 9 says we're working with a quadratic sequence. They say the second term in the sequence is 7, the third and fifth terms are those two respectively, and they ask us to determine the second difference of the sequence. Different way to ask this, so let's see how we deal with this. I'm going to say the first term is x, make it x1. Then the second term they say is 7, okay, the third and the fifth, the third is 19, so we don't have the fourth term, so I'm just going to call it x2, and then the last term that they give us is not 16 but 61. Okay, now they ask us to determine the second difference. Now they told us it's a quadratic sequence, so what do we know? We know the second difference is constant. The first difference is not constant. But let's see, what do we do? To find the difference here, I take this term and I minus x1 from it. Okay, x1. The difference here is 19 minus 7, so that difference would be 12. The difference between these two terms will be x2 minus 19, and the last difference there is this one minus this one, 61 minus x2. Now please note that these aren't constant. That's the first difference. The second difference is the difference that is constant. That difference is 12 minus this. So this will be minus 7 plus x1. The difference here is x2 minus 19 minus this 12. And then the third difference will be 61 minus x squared minus x2 plus 19. Don't make a mistake with this negative remaining negative. Now what do we know? We know that this is equal to that and that is equal to that. Okay, so if I clean the third one up and I clean the second one up, and actually I can clean the first one. So this is 5 plus x1. This here will be x2 minus, now remember you've got to take 19 and you've got to add 12 to it. That's 20, 31. Over here I have 61 plus 19. That gives me 70, gives me 80 minus 2x. Now I know that this is equal to that is equal to that. Sorry, that's a x2. Okay, so I'm looking to solve x2 and x1 for that matter. I know that these two are equal to each other. So I'm going to start off and I'm going to say, okay, that means that 80 minus 2x2 has got to equal x2 minus 31. I collect the x2's together. That gives me minus 3 times x2. And I collect to the other side the 80 and the 31. Now remember, the 80 goes over, becomes a negative. So 80 and 31 together gives me 111. So this will be equal to minus 111. And now I have to divide that by 3. So what do I get? I get that x2 is indeed 37. Now that's all I needed. They asked me to find the second difference. So in fact I don't need the x1. With this then in my handbag, I'm going to say, cool, the second difference, D, is, let's use the smaller one, x2, which is 37, minus the 31, and 37 minus 31 is indeed 6. So your second difference is a constant 6. Okay, folks, so please, you saw the layout here. You've got to know how the quadratic sequence works and what gives you particular values in the sequence. It's a lovely question. It's different from the ones that we usually ask. Okay, please remember to like the video if it helped you, and also to subscribe to the channel.